In this video, I'm going to show how you can use determinants to find the area of a triangle. So let us draw a triangle in their XY coordinate system. And here is this nice arbitrary looking triangle. Point A, B, and C. And point A is some x1, y1. And point B is some x2, y2. Point C is x3, y3. Of course, this is their x-axis and this is the y-axis. And we want to find the area of this triangle using determinants. Now the first thing I'm going to do is I'm going to drop 3 perpendicular lines from A, B, and C. And we'll call these points D, E, and F. And the x values didn't change. Point D is going to be x1, 0. Point E is going to be x2, 0. Again, because these 2 points have the same x value. And point F is going to be x3, 0. Now, if you consider this, that is D, E, A, and B. It is a trapezoid. And to the right is another trapezoid. Point B, E, F, and C. We'll call this trapezoid 1, trapezoid 2. Now, this here is the area of trapezoid 1. And this here is the area of trapezoid 2. Now, if I add those 2 trapezoids, I definitely have the area of the triangle included in that area. But I don't want this. I don't want this area. I want to remove this area down here. Well, that's also another trapezoid. This trapezoid is D, F, C, A. This is trapezoid 3. And like I said, I want to take it away. Okay, so this is, the area of the triangle will be that area trapezoid 1 plus the area trapezoid 2 minus the area of this stuff down here, the area of trapezoid 3. Okay, so now let us find the area of the trapezoid. Remember, this point is x1, 0. This is x2, 0, x2, 0, x3, 0. A is x1, y1. Point B is x2, y2. Point B is still x2, y2. And point C is x3, y3. And point D is x1, 0. Point F is x3, 0. Point A is still x1, y1. And point C is x3, y3. Now, there's going to be a lot of alphabet soup here, but this is the way this problem works. Now, the next thing I want to talk about is what is the area of a trapezoid. Now, these are the two sides that are parallel. A trapezoid is a quadrilateral, a four-sided figure where two sides are parallel. This is the height, and these are the bases, base 1 and base 2. The area is 1/2 times the height times the sum of the two bases. It's 1/2 times the height times the sum of the two bases. Okay? So let's go right ahead. So the area of the triangle is, well, the base of trapezoid 1 is x2 minus x1. Sorry, not that that was wrong, but we're supposed to write half first. The half times the base, which is, sorry, the height, which is x2 minus x1, times the sum of the two heights. Well, this height, it goes from 0 to y1. That height is y1. This height, it goes from 0 to y2. That height is y2. So here is the area of trapezoid 1. Great. Let us add on the area of trapezoid number 2. It's 1/2 times the height. The height is x3 minus x2. Times the two bases. Well, this base, it goes from 0 to y2. That height is y2. Plus this height, it goes from 0 to y3. That height is y3. So that is the area of trapezoid 2. And we're supposed to take away the area of trapezoid 3, which is 1/2 times the base. Well, this is the base. It goes from x1 to x3. So the length of that base is x3 minus x1. Like always, it's the right endpoint minus the left endpoint if you want to find a horizontal distance. x3 minus x1 times the sum of the heights. Well, this height, sorry, base, this base goes from 0 to y1 plus this base goes from 0 to y3 plus y3. Now, that's the area of the third trapezoid. If you notice, each term, the underlined things, have a 1/2 in common. So I'll factor it out. Let us actually multiply this out, and then that out, but add it, and then this out, and of course subtract it. So in the first one, in here, when we multiply, we get x2y1 plus x2y2 minus x1y1 minus x1y2 plus. I factored out the half, so I just multiply those two. I get x3y2 plus x3y3 minus x2y2 minus x2y3. Minus, because I'm down here now, does say minus. I factored out the half. I multiply those out. I get x3y1 plus x3y3 minus x1y1 minus x1y3. Okay. Now, let's just look at the negative ones. We're taking away x1, y1. Are we adding that back? Oh, I'm also taking away negative x1, y1. You subtract the same things, they're gone. I have negative x1, y2. And am I adding that back anywhere? x1, y2. I don't seem to see it. Remember, that's a y3. Okay. Negative x2, y2. I have x2, y2 minus x2, y2. So those cancel. I'm also taking away x2, y3. Am I adding it somewhere? I don't see it. But if I'm wrong, we'll find it later. I'm also taking away x3, y1. I don't see that anywhere. I'm taking away x3, y3. I have x3, y3, and I'm taking away exactly x3, y3. That will cancel. The next two terms are really being added. So what I have is 1/2 times, just going to recopy what I didn't cross off yet, x2, y1 minus x1, y2 plus x3, y2 minus x2, y3 minus x3, y1 plus x1, y3, because minus a minus becomes plus. So that's what I have. Now, if you look at this determinant, remember the 3 points of the triangle was x1, x2, it was x1, y2. No, it wasn't. It was x1, y1. x2, y2, that was point B, and point C was x3, y3. Now, if you just put ones here, let us compute this determinant. The easiest way to compute a 3 by 3 determinant is to write down the determinant, which I just did. Just clean it up a little bit. And then repeat the first two columns, this column and that column. x1, x2, x3, y1, y2, y3. And then you do what I was told is called the spaghetti rule. You multiply those three, which is x1, y2, plus the product of those three, which is y1, x3, plus the product of these three, which is x2, y3, minus, now you go the other direction, minus x3, y2. Since I factored out the minus, I put a plus here, minus that, which is x1, y3. And then I take away that product, which is x2, y1. Now, if you look at this here and this here, they're gonna be the same. This has x2, y1. Why am I getting minus? Okay, so let me just factor out a minus sign. Actually, it's either this is, remember, area is positive. It's either this or it's negative this. x1, y2 plus y2, y1, x3 plus x2, y3 minus x3y2 plus x1y3 plus x2y1. It's going to be one of those two. It's going to be the absolute value. Okay, so I have plus x2y1. You know, if you have a minus in front, and then, so this last line is just minus times this, because there's another minus there, is x3y2 plus x1y3 plus x2y1 minus all of this, minus x1y2 plus y1x3 plus x2y3. Okay. Now, once again, I have y2, y1. Got it. Plus. I have minus y1, y2. Minus y1, y2. Plus x3, y2. There it is. x3, y2. Minus x2, y3. Minus in front, x2, y3. Minus x3, y1. Multiplication commutes. Plus x1, y3. I got it. The only thing I have to do is put the half in front. This here is the area of the triangle, with one exception. I have to take the absolute value. As you saw, this one didn't work, but when I negated this long formula, long expression, I got this one, and this one did work. Sometimes that one will work, sometimes this one would work. Just take the absolute value. So again, let's just recap. If you have, and I know what I'm saying is true because we just proved it. I don't even need all this anymore. Let me just redraw it. If you have the following. If you have a triangle where point A is x1, y1, and another point is x2, y2, and another point is x3, y3, it turns out that the area of the triangle is nothing more than 1/2 the determinant of 1 point, or second point, oops, a third point, and then 1, 1, 1. But you have to take the absolute value. Now, why is it reasonable to be off by a sign? Okay, you have to remember that the determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1, and let me interchange the first two rows. x2, y2, 1, x1, y1, 1, x3, y3, 1. These are not equal. They differ by a sign. But does the area of this triangle depend upon which point we write first? First I wrote this point, and then that point, and then that point. And here, first I wrote point B, and then point A, and then point C. Well, if somebody says, well, you have to go in alphabetical order, fine, you're right. So I'm going to call this B, and this C, and this A. Okay, switching switching the points around shouldn't make a difference. So how do we get this determinant and this determinant to be equal? Right now they differ by a sign. And the answer is, don't take the determinant, but take the absolute value. Okay? These bars are absolute value. That is, this here is a real number multiplied by a half. In case it's negative, call it positive. Okay, so you can be off by your sign. So, always take absolute value. And in case you forget to take absolute value and you get a negative answer, you say, oh, yeah. I was told to take the absolute value. Why? Because you can switch those two rows and it's the same triangle. This determinant represents the same triangle. This determinant and this determinant represent the same triangle. It's just that the rows are out of order. But how can the rows be out of order? They are just the points of a triangle. I cannot write down a triangle and you say, oh, come on. That's point 1 and that's point 2 and that's point 3. Everybody knows that. Nonsense. And if for some reason you say, well, come on, everyone knows you go clockwise. Wonderful. I'll rotate this. I will rotate this triangle where this is 3 and this is 1 and this is 2. So, of course, this is now 1 and this is 2 and this is 3 because everyone knows you go 1, 2, 3. I can get this to be 1. Order won't matter, folks. I want to stress that. Okay, if you like videos like this, please subscribe to my channel. See you in the next video. Watch and learn.